Good morning, students. How are you all? I am also fine. Students, in previous class, we have discussed about the topic ionization enthalpy, and today we will do some questions related to the ionization enthalpy. So, our first question is, which of following order is correct for first ionization energies of following elements? Some elements are given to us, so we have to arrange these in order of the first ionization energy. Students, here elements are boron, beryllium, boron, nitrogen and oxygen. First of all, we will write configuration for them. Beryllium, what is the atomic number? 4. So configuration is 1s2, 2s2. 4b, boron. What is the atomic number for this? 5. So its configuration is 2p1. Then for nitrogen, what is the atomic number? 7. Configuration 2p3. And atomic number for oxygen? 8. Its configuration is 2s2, 2p4. Students, in general trend, you know very well, if we move left to right in a period, atomic size decreases. Atomic size decreases. If atomic size decreases, then ionization enthalpy will goes to increase. If we talk about the general trend of the ionization enthalpy. But student, you know very well, there are some different factors like penetration effect, like shielding effect, and electronic configuration also affect the ionization enthalpy of an element. Okay, so we will see those factors also. Then we will tell about the ionization enthalpy order. So you can see, first beryllium in period, then boron is arranged, then after boron carbon, then nitrogen and then oxygen. Means in general trend, ionization enthalpy order should be this one. But student, you can see here this nitrogen, it has half filled p orbital. It has a half filled p orbital. So this configuration is more stable. So what will happen here? Here ionization enthalpy for nitrogen will be greater than the oxygen. Okay, and here in between beryllium and boron, here s orbital is the fulfilled orbital here. Here it is fulfilled orbital, and you know very well fulfilled orbital, it is more stable as compared to boron. So further ionization enthalpy for beryllium is greater than the boron. So students, from here we can conclude that ionization enthalpy for nitrogen will be maximum than for oxygen, because when we move in period, then ionization enthalpy goes to increase. But due to some exception and due to the stable configuration, nitrogen has more ionization enthalpy than oxygen, then beryllium and then boron. So we will see the option in which this order is given to us. So in which it is given, nitrogen has maximum, then oxygen, then beryllium and then boron. So C, option number 3 is the correct option. Okay, so this question is clear to you or not? You have any doubt in this? No. Okay, so now move to the next question. Question number 2. Question number 2. The correct order of second ionization energies of carbon, nitrogen, oxygen and fluorine. Students, here order for second ionization enthalpy is asked to us. Okay, so here elements are carbon, nitrogen, oxygen and fluorine. First of all, students, if we will write the configuration for that. What is the atomic number for carbon? 6. So what will be the configuration? 2, 1s2, 2s2, 2p2, 2p2. Okay, because there are only 6 electrons. And what will be the configuration for nitrogen? 1s2, 2s2 and 2p3. What will be the configuration for oxygen? 2p4. And for fluorine? 2p5. Student, if we want to remove the electron from outermost shell, if we want to remove first electron, so the energy which is required for removal of the one electron from outermost shell, that is known as the first ionization enthalpy. So first of all, we will remove only one electron. After removal of the one electron, this carbon converted into the C plus. After removal of one electron, it convert into the C plus. And what will be the configuration? Here in P, only one electron will be there. Only one electron will be there. In case of N plus, here two electrons will be there after removal of one electron. And here, in case of the oxygen, there will be 3 electrons. Okay. Then for fluorine, there will be the 4 electrons. Students, in general way, if we talk about ionization enthalpy goes to increase when we move from left to right. But here, if we talk about the second ionization enthalpy, so here, in case of oxygen, p orbital is the half-filled orbital here. P orbital is the half-filled orbital. And you know very well, half-filled orbitals, which element have, that is the more stable. That configuration is the more stable. So it requires more amount of energy to remove the electron. Okay. So here for oxygen, ionization enthalpy will be maximum. Second ionization enthalpy will be maximum. So you can see the option, means option 1 we cannot consider. Option 4 we can also not consider. So we can consider these two options. Okay. Now we will see. We will compare the ionization enthalpy for nitrogen and fluorine. So when we move from left to right, then ionization enthalpy goes to increase. So ionization enthalpy of the fluorine will be greater, will be more as compared to ionization enthalpy of the nitrogen. So this option 3 will be the correct option. It is clear to you or not? So student, first of all, you will write the electronic configuration, and on behalf of the electronic configuration, which one is the more stable, which one is the less stable, you will give the answer. Okay. If configuration is more stable, then it will have the more amount of the ionization enthalpy. It will require more energy to remove the electron. It is clear to you or not? Yes. Now move to the next question. Question number 3. The incorrect statement among the following. Students, we have to tell about incorrect statement here. Okay, so we will see statements one by one. Here statement 1 is the first ionization potential or the first ionization energy, okay, of Al, aluminium, is less than the first ionization potential of magnesium. He is saying that first ionization enthalpy of aluminium is less than first ionization enthalpy is less than the first ionization enthalpy of the magnesium. So this one is right or wrong? Tell me. This statement is correct or not? Students, you see, if we talk about the period lithium, second period, lithium, sodium, after sodium which one come? Magnesium, not potassium, beta. Magnesium, aluminium, then silicon. So in this way you can see, when we move from left to right, then ionization enthalpy increases. So according to this, ionization enthalpy the ionization enthalpy for aluminium should be greater than the ionization enthalpy of the magnesium. But students, second concept, we will see the effect also. We will see the effect also on which ionization enthalpy depend. Okay. So first of all, we will write the configuration. Here magnesium. What is the atomic number for magnesium? 12. Write down the configuration. 1s2, 2s2, 2p6, 3s2. Okay. Then write down the configuration for aluminium also. For aluminium, atomic number is 13. So configuration is 1s2, 2s2, 2p6, 3s2, then 3p1. Okay, students. So you can see here, in case of magnesium, s orbital is the fulfilled orbital. S orbital is the fulfilled orbital. Due to its configuration, it is more stable. It is more stable. Because due to its configuration, magnesium is more stable. So ionization enthalpy for magnesium will be high. It will be more. It is clear to you or not? So student, this is not the incorrect statement. This is the correct statement. Here ionization enthalpy for aluminium is less than the ionization enthalpy of the magnesium. Why it is? Due to configuration of the magnesium. Because due to fulfilled s orbital, magnesium is more stable as compared to the aluminium. Clear to you or not? Okay. Now, read the statement second. What is the statement? We will see. Students, here statement second is the second ionization potential of magnesium is greater than the second ionization potential of the sodium. Means now we will see the second ionization enthalpy. Okay. So first of all, write the configuration for magnesium. For magnesium, it is 1s2. You have already written 2s2, 2p6 and 3s 2. Okay. Then for sodium. Sodium it is 1s2, 2, 3s1. But it is talking about the second ionization enthalpy. So if we remove the first electron, after removal of first electron, it convert into the Mg plus, and Mg positive has the configuration 3s1, 3s1, and after removal of one electron, sodium convert into the Na plus, and its configuration will be the 1s2, 2s2, 2p6. Means after removal of one electron, sodium is attaining more stable configuration. It is attaining the configuration of a noble gas. It is attaining the configuration of the neon. Okay, neon is the noble gas. Okay, so from here, because it is attaining configuration of the noble gas, now it is difficult to remove electron from this cell because it is fulfilled cell. So second ionization enthalpy for sodium will be greater. For sodium will be greater as compared to the magnesium ion, as compared to magnesium. Okay, but he is saying that second ionization enthalpy of magnesium is greater. No, second ionization enthalpy for sodium is greater as compared to second ionization enthalpy of the magnesium. Okay, so here this is the incorrect statement. So what will be the answer? Second. Second option is the correct option. Okay, now we can see third one also. The first ionization potential of sodium is less than the first ionization enthalpy of the magnesium. No, you know very well, student, if we move from sodium to magnesium, so we are moving left to right. When we move left to right, then size decreases. If size decreases, then ionization enthalpy increases. So ionization enthalpy of magnesium will be more, and here it is saying sodium is less than. Okay, so it is clear. Here magnesium has greater ionization enthalpy than sodium. So this is the right statement. The option 4, the third ionization enthalpy of magnesium is greater than the aluminium. It is also correct option. So student, here option B is the incorrect, and that is the answer of this question. It is clear to you or not? Yes. Now see the next question. Here question number 4 is the first ionization potential of sodium, magnesium, aluminium and silicon are in order. Okay, so here sodium, magnesium, aluminium and silicon. If we talk about the general trend, then left to right, ionization enthalpy increases. But student, we have already discussed in previous question that magnesium, it has more ionization enthalpy as compared to the aluminium. Why it is? Due to its more stable configuration, because it has configuration 1s2, 2s2, 2p6, 3s2. Here s orbital is the completely filled orbital. Is the completely filled orbital. So this configuration is the more stable. Okay. Due to stability of the configuration, it has more ionization enthalpy as compared to the aluminium. Okay. So what should be the order? Order should be the silicon has maximum. After silicon, magnesium. After silicon, magnesium. Then aluminium and then sodium. So this should be the order. Now see in which option this order is given to us. Which one is the option? In which silicon has maximum. So this is the option. In this, silicon has a maximum, and magnesium has greater than aluminium also. It has a greater than aluminium also. So this one is the right option. This one is the right option. It is clear to you or not, students? Okay. Now, our next question is the first ionization energy in electron volts. We will measure the energy in electron volts. This is the unit, electron volts of nitrogen and oxygen. Atom are respectively given by. Students, here first ionization enthalpies are given for nitrogen and oxygen. Nitrogen and oxygen. So we do not know about the data. We do not know about the data. But student, what will we see? We will see the trend. We will see the trend. So in trend, you know very well, due to the configuration of the nitrogen. Here it has half-filled p orbital, which make it more stable. Which makes it more stable. So due to this, ionization enthalpy of the nitrogen is more as compared to the oxygen. So you can see here, this is the ionization enthalpy for nitrogen, and the second one is the ionization enthalpy of the oxygen. Means ionization enthalpy of nitrogen should be greater as compared to ionization enthalpy of the oxygen. So in first option, it is greater than this, okay, but in second, both ionization enthalpy of nitrogen is less, so it is not correct option. Both enthalpy are the same? No, they are not same. Both are same? No, both are not equal. So ionization enthalpy for nitrogen is greater as compared to oxygen. So this should be the correct option. In this way you can solve. Then question number 6, students. Which of following species has the highest ionization potential? Highest ionization potential. Tell me which one has highest. What is the configuration for Li plus? Lithium, what is the atomic number? 3. So 1s2, 2s1. But it has lost its one electron because it exists in ionic form. So configuration is 1s2. Okay. Here magnesium plus. What is the configuration? 1s2. 11 electrons are there. 1s2, 2s2. 2p6, 3s1. Here, in case of aluminium, 1s2, 2p6, 3s2. Okay, and in case of neon, 1s2, 2s2, 2p6. Students, you know very well, when we move left to right, so in right side, neon is present in outer right side. Okay, so here you can see it also has more stable configuration. It also has the configuration of the noble gas. So it is noble gas configuration. So this configuration is more stable. This configuration is the more stable. This is also stable. Yes, students. So this has also noble gas configuration, but you know very well, when we move left to right, then ionization enthalpy increases. So ionization enthalpy will be highest for the neon. It will be highest for the neon. It is clear to you or not? Yes. Then students, question number 7. The set representing correct order of first ionization potential. Here elements are potassium, sodium, lithium, beryllium, magnesium, calcium. Okay, some elements are given to us. So which one is the correct order for the first ionization enthalpy? First one, potassium has greater ionization enthalpy than sodium, than lithium. It is correct or not? Tell me. It is correct or not? What is the position of these elements in periodic table? These are the element of the group number first. Lithium, sodium, potassium. When we move down the group, top to bottom, what will be the trend? Ionization enthalpy decreases because size increases. Ionization enthalpy will decreases. So ionization enthalpy for potassium should be minimum. Okay. Here it is given maximum. So this one is not the correct option. Clear? Now, see this beryllium, magnesium, calcium. These are the elements of the group number second, alkaline earth metal. In this, beryllium, magnesium and calcium. So down the group, again ionization enthalpy decreases. So this one is correct or not? Why? Calcium has least, has minimum, and beryllium has a maximum. So down the group it is going to decreasing. So it is correct or not? So this one is the correct option. This one is the correct option. Here boron, carbon and nitrogen. When we move left to right, then ionization enthalpy increases. So this should be the order. So again it is wrong. Here silicon, germanium, carbon is also wrong. It is also wrong because when we move from carbon to silicon, down the group ionization enthalpy decreases. So again it is wrong option. So option 2 is the correct option. It is clear to you or not? Okay. Students, among the following elements, okay, some elements are given to us whose electronic configuration are given below. Their configuration is also given to us. The one. Okay, students. So here some elements configuration is given to us. Student, this is your homework for today. You will solve this question. You will try to solve this question yourself. Okay. If you have any doubt, then you will discuss in next video. So thank you. Have a nice day.